All right. Hi, everyone. Welcome to today's meetup. My name is Dalia, and I work for Elastic's community team. Today, we're here to hear from Milos, who is an education engineer in Elastic, and he's going to talk to us about Elastic Maps application. We're going to take all of the questions in the end. So, yeah, I hope you enjoyed. Go ahead, Milos.
Thanks, Dalia. Thanks for a brief introduction. I hope everyone is able to hear me and see me well. So before we start for today, I'm just going to briefly introduce myself and my background. So as Dalia mentioned, I am an education engineer at Elastic with the company for almost 2 years now. And on daily basis, I'm teaching students and users of Elastic Stack on different topics, such as the stack itself, but also different solutions and how users can derive the most value from different applications inside of the stack. My background is in software engineering. I used to work as a backend engineer for different startup companies. And interestingly enough, I started using Elasticsearch in 2015 while we were still on version 1.5. And then in the past few years, working for different companies, I've been able to use the stack for different use cases. Today's topic will be Elastic Maps application. And we're going to focus a bit more on how we can visualize geodata. So we're going to cover a few different topics there. First, we're going to start with the question that always arises. So what is Elastic? What is Elastic Stack? What is Elasticsearch? When I first started working for Elastic, I used to explain to people that I have a new job and I'm working as an education engineer for Elastic. And then it took me usually about 5 minutes until they would stop me and say, wait, you work for Elasticsearch. And then the whole story about explaining the differences and so on. So we're going to briefly touch on that. And then we're going to immediately move into Elastic Maps app. We're going to look at few demo maps. We're going to understand what is necessary for us in order to visualize the data. But then also we're going to briefly touch on how do we get the data. As we know, oftentimes getting the data and preparing the data is the toughest part of the job. So where do we acquire the data? How do we enrich the data? How do we prepare the data so that Elastic Maps application can work with it effortlessly? We're going to touch as well on Elastic Maps service and understand what supports Elastic Maps application. And then after, let's say, 10 minutes or 15 minutes of talking about stuff, we're going to do one big demo and create one map ourselves and make it as nice to the eye as possible. So first things first, what is Elastic? Elastic is a company. This is Elastic. All these people who gathered once a year when it's not COVID in the same place somewhere in the world and work for a week together in an internal event and discuss things, create strategies, and decide where the company is going to move in the following years. Elastic as a company is behind Elastic Stack, and we're going to see a bit more on the Elastic Stack in a bit. But before we move on to the technicalities, it's very important for me to share just a bit on the company because I think it's a very unique place to work in. And of course, as you know, Elastic is behind the Elastic Stack, which is open source, and it's a distributed company. So there are around 2,000 employees, 2,000 of my colleagues at the moment that work from 40 different countries in the world. And we all work remotely, and we used to work remotely even before we were forced by the current situation. So we tend to follow the philosophy of the product internally in the company. We have a distributed product, and we also are a distributed team. And we take a lot care about our source code. So the same way as we have the source code for the product, which is publicly available. So as you know, you can just go to GitHub and check the code for Elasticsearch or for Kibana. In the same way, we have a source code for the company, which shares with everyone what are the values of the company. And it is a great place to work in. And yeah, it's very nice for me to be able to share this with everyone and say how nice it is to work with colleagues that always push you to become better, to learn more, and then of course also spend time privately and work on your own stuff. So let's talk a bit more about Elastic Stack and give you a bit of an introduction on where do we find those maps, how do those maps work. Well, Elastic Stack consists out of 4 different products. So we have Kibana, Elasticsearch, Beats, and Logstash. Elasticsearch is the core of the stack. Oftentimes, people confuse Elasticsearch with Elastic, but Elasticsearch is a product that is at the core of the stack we like to refer to as Elastic Stack. And Elasticsearch is in charge of storing the data, querying the data, running aggregations, and it's the brain of the whole stack. Kibana connects directly to Elasticsearch, and it is the place where we can find different applications that send requests to Elasticsearch, receive responses back, and then render all these things inside of the UI. Through Kibana, you can manage the stack, you can discover different data, you can create graphs, and of course, you can create maps, as we're going to see today. And Beats and Logstash are those 2 products that actually allow us to additionally enrich or transform the data before it enters Elasticsearch so that it can be used effortlessly. Now, of course, Elastic Stack is a tool, and a lot of users, a lot of community members understood that this tool can be used in many different ways. For that reason, you're going to hear a lot about Elastic Enterprise Search, Elastic Observability, Elastic Security. So different solutions that are based on the Elastic Stack, but of course extend its usability and focus a bit more on specific use cases. And Elastic Stack can be deployed anywhere. So you can, of course, just pull the code from GitHub and run it locally. You can download it prepackaged, but you can also run it in the Elastic Cloud or use tools such as Elastic Cloud Enterprise and Elastic Cloud on Kubernetes to orchestrate the deployment yourself. Now, the question is, where are maps in this whole story? Well, maps are a part of Kibana. But as we mentioned before, Kibana can't do anything on its own until it's connected to Elasticsearch. So you need to have at least one instance or a node of Elasticsearch, and then you need to connect Kibana to that node. And only then you will be able to access the interface and inside of that interface find Maps app. So what is Elastic Maps app? This is a simple visualization or representation of the map without any layers on it. But of course, let's look a bit back in the history of maps, and geo-search and geopoint and generally geographical data have been a part of Elasticsearch since a long time ago. So even if we look all the way back to version 0.9.1, we can find there that it was the first mention of actually using something like geopoints and querying these geopoints in order to find maybe all the locations that are within a certain radius from a reference point, or draw a polygon and find all of the documents inside. In fact, that was the main reason how I personally got involved with Elasticsearch 5 years ago. I was working for a small startup company, and we had the need to index documents that represented news articles. And then we needed to query those news articles millions of times, of course, for millions of users, but then also do that many times per minute. So every time a user or their phone would change the location, we would have to query for hyperlocal news. And we were looking for a solution, and Elasticsearch, even back then, of course, offered that for us to index some geopoints and then run these different queries. Now, from version 7.3, so if we fast forward all the way to version 7.3, Elastic Maps application has general availability. So even before then, I believe since 6.7, it was still in beta version, so you were able to use it, but it's generally available since version 7.3. And you do need to have a license for it, but you need to have at least a basic license, and basic license is for free. So of course, that means that you can just download it, get the license and use it. You cannot find it in open source version, and you cannot find it, for example, in Amazon Elasticsearch service because they are not under basic license. Now, that application, Elastic Map Service, is powered by Elastic Maps Service. These are two separate things. So of course, we have Elastic Maps application and Elastic Maps Service, and we're going to touch on that in just a bit. And why do we even discuss this today? Well, because we have vast number of use cases for using maps. Security or SIEM can be one of them. Oftentimes you have events, as we like to refer to the things that happen that represent a moment in time that have typically its source or destination. And we want to use maps to plot these events and to maybe look for anomalies or look for potential sources or of threats. If we look at observability, any service that you have, any website, anything that you use to monitor or observe your system, you might want to know where your users are coming from. How often are they accessing your service? From which cities, from which IP addresses, from which countries, and so on. There are many, many numerous use cases, of course, to be able to see your data plotted on a map in near real time and react to it, filter results, and so on. So let's look at some maps now. I'm going to stop sharing this presentation for a second, and you should be able in a few moments to see my Kibana. So here we are in Kibana, and this is the home page. So let's go and check out some maps. How do we do that? Well, we have here add sample data. So Kibana allows us to import some of the sample data sets together with visualizations, preloaded maps, dashboards, and so on. So I've done just that. I preloaded 3 different data sets. And now I'm going to go and find this maps application in Kibana. It's enough for me to open the left-hand side menu and choose inside of Kibana maps application. There are already 3 preloaded maps here, and one of them that I use as a test reference. So I'm going to open, for example, logs maps. And if we open this map, we're going to zoom out here and we're going to start showing some data. Now, we must not forget one thing that is always first thing that you need to check everywhere in Kibana, and this is the time picker. Oftentimes, you're going to be tricked into thinking, well, I don't have any data, something doesn't work. But first thing that we need to do is say, okay, let me look at, and then I'm going to say here, 5 years worth of data to be on the safe side. And now the data starts to appear here. So as we zoom in and out of the maps, we can see that we have requests coming by country and total requests and bytes for each of these moments. And as we zoom in, you can notice that these circles start becoming more granular. As you zoom out, they're becoming less granular. So this is just one type of a layer that we can create inside of maps. We're not going to dig too deep into this because we're going to create it ourselves when we start from an empty map. But as you can see, as I zoom in inside of city, I get to the point where I can find actual requests. So another interesting thing, as I zoom out, actual requests disappear. So I don't need to see them because they would take too much space. But as I zoom in to a given city, Kansas City in this case, actual requests start appearing. I can see the details of the request just by clicking on the actual dot. And I can see client IP, timestamp, so some of the fields inside of that particular document. This plus sign will allow me to dynamically create a filter. So maybe now I want to see all of the requests from client IP 79156. So I'm going to click on this filter, and this will dynamically create filter inside of my maps application. Now, let's go back and after seeing some maps, let's discuss about the data. So of course, Maps application will allow us to render the data that we have inside. But where does this data come from? Well, in Elasticsearch, we have this concept called index. And indices allow us to store the data that shares common fields, that shares common grouping. And Kibana allows us to create something called an index pattern that is simply a pointer to one or more multiple indices that contain some data. And these maps work with index patterns. So I want to understand the source of the data for this particular map. We're using logs, total requests, and bytes. So I'm going to go back to the menu, and I'm going to choose here stack management. And I want to see which kind of index patterns I have inside. One of these index patterns is Kibana sample data logs. And this is exactly the index pattern that has been used in order to provide the source of the data for the map. If I extend to the further rows, I'm going to see, okay, geo.coordinates field is of type geopoints. So this is what I really need in order to represent some data inside of my maps. So let me just quickly go back to the slides and let's discuss a bit more on what kind of data you need to have in order to use Elastic Maps application. So when we talk about data sources or data that we need in order to use Elastic Maps application, we mentioned index pattern, index, and mappings. Now, of course, data needs to be inside of an index, and you need to create an index pattern for that index inside of Kibana. But even more so, data needs to be properly modeled or ingested to Elasticsearch. And geopoint data type is something that you will need if you want to represent coordinates inside of a map. Now, this is, of course, not the only option. You can also use actual names of countries, regions, or cities in conjunction with Elastic Map Service, which is something that we're going to see in a moment. Another option is to simply upload your data in case if it's in CSV or GeoJSON format. So you don't necessarily need to create geopoints by indexing data in different ways. You can just upload CSV, upload GeoJSON, and then instruct to Elasticsearch how to transform that data in a format of geopoints to be used by geoqueries and, of course, Elastic Maps. And in the end, an alternative option is to use pipelines. So what if you don't have any location information inside of your documents, but for example, you have an IP address, which is a common scenario in case you have some web access logs data and so on. You can use this GeoIP processor, and you can instruct to Elasticsearch to intercept every document that contains an IP address, to take that document and to check the IP address and to derive the location, coordinates, country name, city name from the IP address and insert it to the source of your documents. In that way, you can now work with geopoints again and represent data on Elastic Map Service. So let's do a brief presentation of that. So what do I need to do in order to start using maps? I'm going to jump again and quickly share my other screen here. So if we go back to our Kibana, I'm going to go to DevTools. And inside of DevTools, I am going to create a simple index. And this index is going to contain just one field of type geopoint. So let me do that. I'm going to put index 001 with type of the fields geopoint. And now if you want to index some location data, we can do it in multiple different ways. I can start with geopoint as an object and simply index a document that contains location field and then lat and lon, shortened for latitude and longitude, with the appropriate coordinates. I can simply go and index this document. I can also index the geopoint as a string. So it doesn't have to be an object. It can just be a string with comma separated value where the first element represents latitude and second element represents longitude. I can also index it as a geohash. So bear in mind, this is all the same field, the same mapping, but I'm just providing different source of data. So here's a geohash. Here's a geopoint as an array. So I have an array of values, latitude, longitude. And I can also use geopoint as WKT point primitive and index that as well. How do we make sure all of these things worked? Well, of course, I expect now to have an index with 5 documents, and these 5 documents should all have their own coordinates, latitude and longitude. So I'm going to perform a simple query, and I'm going to use the query type of geobounding box. This type of a query allows you to define a box with only 2 coordinates, so top left and bottom right. This will create a rectangle, and you want to return all of the documents that contain geopoints within that rectangle. So I'm going to perform this search request, and I'm going to get 5 results back. So all of my 5 initial documents were valid. So this is what you need to do in order to prepare data. You need to have at least one field if you want to display the actual document on the map that is of type geopoints. But even in case you don't have those geopoint fields, you will be able to interact with the maps by just using the actual values of fields that represent country names or postcodes or region names, and then join that together with Elastic Map Service. So let's quickly show you the Elastic Map Service we were talking about. You can access it by just going to maps.elastic.co, and this is how Elastic Map Service looks like. Now, Elastic Map Service is something that allows you to actually use basemap tiles, to use shape files, layers, and then provide layers on top of that. It is developed and maintained by Elastic, so separately, of course, from the Elastic Stack, which also means that you don't have to wait for the next update of Elastic Stack, or you don't need to update your whole stack if you want to get the freshest version of Elastic Map Service. They update separately from the stack itself, and they're based on OpenStreetMaps. Okay, so this is the base of Elastic Map Service. We also use Natural Earth as well for this service. And what does this service provide to us? Well, if we zoom through this map, we can already see that we have different levels of zoom. So we start with the world map, but then as we zoom in further, we can go all the way down to street level, and then also see inside valuable data for particular locations. So if I zoom in to Amsterdam, which is my current location here, I'm going to be able to see street names, restaurant names, museums, all of the points of interest on my map. Now, on top of that, you have 3 options to choose tile layers. So the default one is this light map. There's also an option with road map dark and the road map desaturated that does not contain all of the information that you have on a regular road map. Interesting thing inside of this Elastic Map Service is vector layers. So you can either choose world countries, but also for different countries, you can find different vector layers. So if we look at the Netherlands here, we're going to find provinces of Netherlands. And if I zoom in now to the Netherlands, I am going to see these vector maps inside. And I'm also going to be able to find with which values these provinces are represented with. Okay, now Netherlands might not be a good example because we can, for example, go to the US where we have counties, states, and zip codes. So if I choose USA states, I can see that for each state, I have name, FIPS 52 alpha code, so 2 code abbreviation, or US dash, again, 2 letter abbreviation. Why is this important for us? It is important because in case we don't have geopoints and we just have fields that contain values for state name or 2 letter abbreviation or Italy provinces, we can join these documents together with vector layers in Elastic Map Service. And this is exactly what we're going to do in our demo. Okay, I'm going to quickly move to making a map actually. So let's do that. Let's start with creating our own map and work through all of these theoretical things that we mentioned so far. So I'm going to share my screen again, and let's go back to Kibana. And I'm going to get out of DevTools and go to Maps application. Now, inside of the Maps application, let's go and create our own map. So we're going to start from an empty canvas and then add things inside. Let's make sure the time picker is fine. We've got the last 5 years worth of data. We have our base layer, so loaded from Elastic Map Service, as you can see in the bottom right corner, using OpenStreetMap contributions. Okay, as I zoom in, and in Elastic Map Service, you have up to 24 levels of zoom. I can go as detailed as I want into any place. And in the bottom right corner, you can also see zoom level. So here we went all the way down to 24. Okay, top right corner. Maybe you can't see as it's really, really small. I'm not sure how the screen is rendered on the Zoom webinar, but this is the biggest zoom we can have inside of the Maps application. So let me start with adding some layers. So on top of this base map, I want to add layers, and I have multiple options here. Upload the GeoJSON that we talked about before, but then also using my indices or index patterns from Elasticsearch, documents or choropleth, clusters and grids, heat map, or point to point. So let me start with point to point. And the requirement for point-to-point layer is that you have at least 2 geopoints inside of your index mapping. We're not able to join different fields from different indices. So you need to have in one single index at least 2 geopoints. So I'm going to choose my test index for today, which is mail delivery. And what we should do before jumping into maps every time is we should quickly check in Discover section, how does our index pattern behave, what kind of fields we have inside. And if I go here and check my JSON formatting, I see I have location, which is of geopoint, so geolocation, and then I also have user geolocation. So I do have those 2 geopoints. I also have some region names, USA states, which is going to turn out useful a bit later when we create the map. So I'm going to jump into Maps application again and create this map and add my first layer, point to point. I'm choosing an index pattern mail delivery, source. So let's visualize how our users, where our users are sending the packages from or mail, and where are they sending the mail to. So user geo.location is going to be my source, and my destination is going to be geolocation. And as soon as I do this, we can see now many lines appearing from any given point here on the map to any other point on the map. I can add this layer. I'm going to name it my sender to receiver layer. I want this layer to appear on all zoom levels. I'm using aggregation of simple type count, and I'm saving and closing this layer. Now, of course, this is not really useful now because we're displaying all of the customers who are sending all of their packages to all of the locations. So very confusing. And ideally, how we're going to use this is we're going to use it by writing some kind of queries inside of the search box. So maybe I'm going to say ID of a user, or in this case, let's say user.age should be greater than or equal to 30. So now I only want to see which users older than 30 or maybe let's say 50 years are sending packages or mail. Okay, for a moment, I'm going to click on this layer and I'm going to hide it. I don't want to display it just yet, and I want to create another layer on top of my maps. I'm clicking on adding a layer, and this time I want to display the documents themselves. So I want to display every piece of mail or every package that has been received at the place of receiving the package. So I'm going to choose documents. I'm going to choose an index pattern mail delivery. And I'm going to say use the field geo.location. Now, here's what happens here. We know that our data set here has 900,000 documents or 900,000 packages or pieces of mail that were sent. And this is more than 10,000. So Kibana here, specifically Maps application, asks us to do three different things. Either limit results to 10,000, so only show 10,000 results, or show top hits per entity, which means I'm going to choose the entity. And for example, that can be geo.country.keywords. And I can set it to 50. So that means for each country, only show me 50 hits. And now as I zoom in to Netherlands, for example, I am only going to see 50 packages destination or mail destination here. Okay. Or I can say show clusters when results exceed 10,000. And then as I zoom out, now my Kibana says, well, I can't really display all of the things at once here. So show me clusters, and in these clusters, show me how many documents or packages you have inside. This dynamically happens. So as I zoom in now, we have specific documents or packages appearing on the map. Okay, so I'm not going to add it like that. I'm going to just say I want to have limit results to 10,000, but this is fine because I have this filter here that says dynamically filter for data in the visible map area. So as I zoom in further down, more dots are going to appear as they get rendered inside of Kibana. Okay, I'm adding this layer. I'm going to name this second layer as mail destination. And I'm going to leave the zoom levels for 224 for now. Let's change the icon as well. So these are pieces of mail. So I can just conveniently choose the icon that represents post. And let's leave the color or change the color to another one. So let's use a bit of it's a darker color here. Okay, perfect. And once I did that, I'm going to save and close this layer. So now we have single pieces of mail displayed on the screen. I want to add another layer now, and I want to add a heat map. Now this heat map is going to also request for an index pattern. So let me choose the same index pattern mail delivery and geo.location geospatial field. As soon as I do that, heat map starts appearing. And of course, it will change dynamically as I zoom out and zoom in to this map. So I'm adding the layer. I'm going to name it as destination heat map. And aggregation can remain count. Grid resolution is one of the three options: coarse, fine, or finest. So you will see the difference if I move to finest. Those parts of heat map actually become much more granular. So we're focusing on more narrow area compared to coarse. And we can also change the color range. I'm going to keep it as the default one. Okay, I'm going to add this layer as well. So now we already have two layers, and arguably this is becoming a bit too crowded. But let's make it a bit more crowded. Let's add one more layer. We talked about documents. We talked about using heat map. Now let's add a layer of type choropleth. So clicking on that, I'm finally going to connect some data that I have inside of my index and join it with Elastic Map Service vector layers. So what is the layer that I want to use? If we look back at Elastic Map Service, I'm going to say, well, let's use world countries. So these are the boundaries, vector layers, and what are the options that I have? Two code abbreviation, two letter abbreviation, the actual name of the country, or three code abbreviation. Okay, let me choose world countries. And now what is the join field? Either 2 alpha code or 3 alpha code here. I'm going to choose 2. And now I need to join this vector layer with some data that I have inside of my index pattern. What is the index pattern that I want to use? Well, here I have more options because now this type of a layer does not require from me to have a geopoint. It only requires from me to have a field that has a value that can be joined with a vector layer. I'm going to use the same index pattern, mail delivery. And then what do I want to connect or join with ISO alpha 2 code? Well, it has to be geo.country code 2 dot keyword. What happens now? Data is joined with the vector maps and displayed on top of our maps application. I'm going to add this layer and I'm going to name it mail items per country. So I want to understand how many packages or pieces of mail are received per each country. So I'm going to say mail packages, mail items per country. Tooltip fields, we want to keep this one as the field we used for joining so we can later filter on it. We can also change the metric. We're going to keep it as count here, but I can also say, well, actually let me change the aggregation to average, and I want to see the average of packages sent per person, or I want to see the average of items in each package. I'm going to keep it on count for now. And I'm going to change the fill color. It's set to by value. I can make it solid, but that doesn't make too much sense because we actually want the color of each country to be in proportion with the number of packages or pieces of mail received. And then we can also change, is it going to be as category or as a number, and how it is going to be displayed. So I can maybe choose a darker color here. And now if I zoom out a bit, I can see that in the US, we have a lot of mail received, a lot more compared to other countries. For example, Libya here has less than Algeria. In Europe, Norway has significantly less than, for example, United Kingdom. So I'm going to go and save this layer as well. But now arguably we got into a problem called too many layers, too many things on in one place, which is not usable for anyone. So we have these world map layers, vectors, then we have, as we zoom in, actual pieces of mail received, then we have heat maps, and this is not usable. So I want to fix that, and we're going to fix it in a simple way. We don't necessarily need to see everything at the same time. So I'm going to argue that when I'm on the world map level, I want to see number of items received in each country. As I zoom in further, I want to slowly start seeing the heat map so I know on which region to focus on. And then when I get all the way down to the city or the region, I want to see the actual pieces of mail or items. So how do I do this? Well, I'm going to first rearrange these layers. I'm going to say I want to have mail items per country at the bottom. So this is the this is the first thing that I want to see. Then I want to have heat map in the middle. And then when I get all the way down to the bottom, I want to have mail destination, so specific piece of mail that has been received. Now, of course, this is not enough. We still have similar problems, so we don't see well because everything is overlaid on top of each other. But what do I need to do now? Now I need to change the zoom level. So if I go and click on edit this layer, it says visibility on zoom levels from 0 to 24. And this is not necessary. So I'm going to say, well, let me see this from 0 to 4. I'm going to go and save it. And then when I get to 4, I don't want to see countries anymore. I want to see destination for heat map. So I'm going to set it 4 to roughly about 10. And then when I get down to 10, I want to see mail destination. So exact pieces of mail that have been received. As I go save and close this now, we can see how the map is much more visible, but all the layers are there and we're moving in between the layers as we're zooming in further. So now we're at the zoom level of 1.74, as we can see in the top right corner. And I'm zooming in. So we can already see a lot of mail being received in United States. I'm going to remove this tooltip. United Kingdom, France, Germany. Of course, I'm going to go and zoom in towards Europe here because I'm currently there. And now we can see this transition between 4 zoom level where heat map starts appearing and countries disappear. So I'm zooming in towards Netherlands a bit more. Heat map, of course, dynamically changes. But then as we get towards Amsterdam, heat map disappears and I start seeing specific items being received in their exact location. And as we know, 24 zoom levels, so I can, if the location is perfectly accurate, I can even see which house has received this particular package. Now I do have to, of course, mention something. This is a fake data set, so we're not really working with real data, so no intrusion to anyone's privacy. This is a generated data set, but I believe it's a very good representative of what we can do with Elastic Maps application. I'm going to wrap it up here because